Hi, today I'm going to show how to use the Casio's fx-570 EX Classwiz calculator to solve this system of linear equation. We have n system of linear equation with n unknown. Solve it using Gauss-Seidel iteration method. Here because the unknown x1, x2, x1, x2, x3 up to xn all are power 1. To apply the Gauss-Seidel iterative method, first of all, we must make sure that equations achieve their convergence criteria. A convergence criteria here means the modulus of a11 must be greater than modulus of a12 plus modulus a13 up to a1n. And then modulus of modulus a22 must be greater than modulus a21, summation of modulus a21 plus a23 until a2n. Later on, the modulus of a33 must be greater than modulus a31 plus a32 until the a33 and so on. Modulus of a and n must be greater than summation of modulus an1, an2, an3, and up to an minus 1, an minus 1. So if not, you have to swap the row, make sure that achieve the convergence criteria before you can apply the Gauss-Seidel iterative method. If not, if the system of linear equation cannot achieve the convergence criteria, then if you apply Gauss-Seidel iterative method, it won't get the converged solution. Once it satisfies the convergence criteria, you can write down the Gauss-Seidel iterative formula. So we want to solve for x1, x2, x3, and xn, which satisfies the left side and right side equations. So from x1, we make it as title, the other variable we bring to right hand side. And then, so that's when we have b1 minus, so here, b1 minus a12 x2 minus a13 x3 until a1n xn. We want to solve for x1, divided by a11. And then for the right hand side, we start with the iteration k, meaning when is k start with 0, with x2 nodes, x3 node, xn nodes, you can get a better x1, that's what x1 at the iteration number 1, which is, that's why if right side is k, so left side you will get better solution, so it will be x1 k plus 1. So similarly for x number 2, the other variable you bring to right hand side and then divided by coefficient of your a22. So the variable at the right hand side is at the iteration. Why you got k plus 1 k? Don't worry. First of all, you have b2 minus a21 x1 minus a23 x3 minus a2n xn divided by a22. Later on, the variable at the left side is always at the step k plus 1. Let's say we consider up to 3 unknown up to x number 3. So x2 is b2 minus a21 x1 minus a23 x3 divided by a22. Since we have the new solution for x1, that's why x1 we put it here. So this is Gauss-Seidel. If we put in x1 at step k, that will be the Jacobian iterative methods. So x3 still haven't found the new solution. That's why x3 still at the step k. So now when we want to find a new solution for x3, x1 we have a new solution already, x2 new solution. That's why this k plus 1, this is k plus 1. So for x3, similarly, we want to find x3. So x3 will be equal to b3. The a31 x1 bring to the left side become minus, this become minus, and then divided by coefficient of a33. And x1 you have here already. This found in step 1, this found in step 2. So that's why x1, x2 we take the new solution. So this is so-called Gauss-Seidel. Okay, and then we focus on the case of 3 equations with 3 unknowns. Okay, I'm going to take how to use a calculate unknown to calculate it. Okay, the new solution for x1 I label as A. So this is an iterative, Gauss-Seidel iterative formula. So the x2 I represent as a B, x3 represent as a C. So we put in the formula accordingly, and we just assign in the right hand side result into variable A. So A stands for the new solution for x1. And then to find x2 we use it as a B. So B equal B2 minus A21. x1 k plus 1. Okay, where we store in A. So that's why this is A. Minus A23. C is actually your x3 k. So divided by A22. Okay, and then C. Okay, x3 k plus 1. x3 we denote as a C. So x1 k plus 1 we found already in variable A. Okay, just now, okay, this right side, once we obtain solution, keep in B. So B is actually the new solution for x2. So x2 k plus 1 is stored in B. Okay, using Kalman, we are going to use this way to solve to solve the system of linear equation. And then, okay, first time you just need to input your B and C, B, C value. We obtain the A. So A value will be automatically substitute in here. C already substitute. Then we obtain the B. Okay, later on B value is here. Okay, A value is here. So we obtain the C. So for the next iteration, we no need to input the B, C value. Okay, we just need to press equal. Then we obtain the whole table of Gauss-Seidel iterative method is some missing point. Okay, once you obtain this table, click when to stop. To stop the iterative. Okay, to stop the iterative, is active. We iterate with the initial value 0, 0, and then we stop it with the maximum value of the iteration at the step xk plus 1 minus xk, the maximum of, we have 3k value here, the 3 value. It takes the iteration number 5 with the iteration number 4 with the 3 value. The maximum value less than the epsilon, which is 0.005, then we can stop. The one we stop, the last case solution is the last iteration. For example, x number 5 here, x number 5 will be the x number 4. This one, the first value, the absolute value 0.002. This one take the magnitude, we've got 0.001. This is 0. The maximum value is 0.002, which is less than epsilon. Then we stop, and the solution is x number 5. This is x1 is 0.6594, x2 is negative 0.2098, x3 is 0.8311. We are going to solve it using the normal calculator mode, and later on using the spreadsheet mode. Let's look at the specific example. Solve this is our linear equation. 2x1 plus 3x2 plus 10x3 equal to 9. 5x1 minus x2 plus 3x3 equal to 6. And then 4x1 plus 7x2 plus x3 equal to 2. Using Gauss-Seidel operations method. First step, arrange the system linear equation so that the matrix A is diagonally dominant to achieve the convergence criteria. So we notice modulus K, if this is a modulus A11, this is magnitude, okay, this value is 2. 2 is not greater than summation of this value and this value. Okay, so however, if we swap second row, become first row, now you see, okay, modulus of phi, okay, is greater, okay, than modulus of -1 plus modulus of 3. So first row is safe. And hence, okay, after you swap, you take the third row at the second row, okay, and you see modulus 7 is actually greater than modulus 4 plus modulus 5. So this thing is correct. And you see now the first row, it becomes the third row. The third row, you have modulus 10 greater than modulus 2 plus modulus 3. So this is diagonally dominant. Okay, if diagonally dominant, then we can solve it using Gauss-Seidel iterative formula. Okay, to solve it using Gauss-Seidel iterative formula, from equation 1 here, first of all, you write x1 equal to 6 plus x2 minus 3 x3. So coefficient of x1 is 5, so it's divided by 5. Okay, mathematically, okay, x2 we put step k, x3 is step k, x1 is step k plus 1. Okay, and I'm going to input into your calculator as 6 a equal to 6 plus b minus 3a divided by 5. And then the column, input everything simultaneously. Okay, second for x2, so 2 minus 4x1 minus x3. 2 minus 4x1 minus x3 divided by 7. Okay, x1 we have a new solution, so x1 this is k plus 1. x3 still don't have, so this is still k. So x2 we got now new solution x2 k plus 1. Okay, in calculator I'm going to x2 as a k, we don't care about the k plus 1 of k. So this is b equal, if we natural display 2 minus k, x1 k plus 1. It is calculate and put it into a. So x1 k plus 1 is, you can call back a, x3 k is still b. This is c divided by c1. x3 is c. Okay, now you calculate x number 3 from equation number 3, which is 9 minus 2x1 minus 3x2 divided by 10. So 9 minus 2x1 minus 3x2 divided by 10. x1 have new solution, so this is k plus 1. x2 also new solution, so k plus 1. So x3 k plus 1. Okay, so column c equal 9 minus 2. x1 k plus 1 is stored in a. x2 k plus 1 is stored in b. So divided by 10. Okay, so this is what the formula here. Okay, so I'm going to input it into now calculator in calculate menu. Okay, a, so alpha a. Okay, is menu number 1 to calculate. So alpha a, alpha calc. Okay, all the red color variable you can use in the formula. Okay, the equal here, if you want to calculate 6 plus b minus 3c divided by 5, store in a, you have to use this equal, the red color equal. Okay. And then I have 6 plus B alpha B minus 3 alpha C, go down, divided by 5. Okay, column. Okay, column, there's a column. So this column over here. Okay, this one. Alpha is. So this column stands for we are going to calculate these things simultaneously. So alpha B, okay, alpha calc, press the button. Press I want equal B, I want this. Press okay. 2 minus 4 alpha A minus alpha C divided by 7. Divided by 7. Alpha C alpha equal, okay, here have 9 minus 2A 2 alpha A, okay, x1 is A, x2 is B, so minus 3 alpha B divided by 10. Okay, before I calculate better, you double check. C is 9 minus 2A minus 3B divided by 10. Okay, B, this one has a B. Okay, B is 2 minus 4A minus C divided by 7. Right? Check the A. A equals 6 plus A. X2 is B, 6 plus B minus 3C divided by 5. Okay. And then, okay, after you put out the formula, you go to build your table. Okay, for Gauss-Seidel or Jacobian, we always start x1, x2, x3 with 0. Okay. So, okay, K0, everything is 0. Now we start the calculations. Okay, first of all, B0 equal C0. Then equal. So you get this is A, which is 1.2 here. Okay. So you notice, okay, I put it B, C just now. Because to calculate A, we put it B and C. We plug in B and C, we obtain A. Okay, and 1.2 is stored in A. Okay, and then you equal, okay, equal A value, just now the 1.2 value will be automatically substituted in here. C just now, we already plug in 0. So we give you the formula automatically, which is, okay, this is negative 0.4. You equal again, okay, change to floating, so you get this C, because A value 1.2, okay, B value negative 0.4, automatically plug in and store in C, so 0.78. Okay, and then if you equal again, you will get to iteration 2. Equal, you go to A. Okay, A negative 0.4. So to calculate A, you need B, right? B, C negative 0.4. If you go down, you see C. You convert in the fraction form. So actually, B value, this now you have here, C value here, then you just equal. Okay, you convert here, you get this iteration K2, the A value. Okay, and then you keep on press equal, you get this is a B value, the latest B value, and then you press equal, this is the latest C value. You got it equal, you convert, okay, this is a A, okay, you equal, you get this is a B, then you equal again, you get this is your C, then you equal, okay, This is now we got B, okay, C. So this is A value equal, this is a B value. Okay, if you want to fix all decimal place, you go shift and move. Oh, in here already cannot. And before that, you shift manoj, fix your number format to 4 decimal place. So negative 0.2997, and then equal again. Okay, this is a C, 0.8311. Okay, we show B for you to see the C. Okay, so this is A, 6594. B, negative 0.2098. Go down. C, 0.8311. Okay, we stop at number 5 because as what I mentioned just now, at iteration number 5, if you take the modulus of x number 5 deduct x number 4, the maximum value is 0.002. You take the fifth row, deduct the fourth row is 3 value, take the absolute value. The maximum value is 0.002 less than epsilon, because we pick at 4 decimal place, we choose epsilon equal to 0.005. So the root of this since our linear equation is 0.9594, x2 is negative 0.2098, okay, x number 3 is 0.8311. Okay, this is using the calculate rule. Okay, later on I'm going to show to you how to use the spreadsheet rule. For spreadsheet, first of all, we put it value 0, go back 0. When equal, you go down, so does it go up, go right 0. So the spreadsheet menu here, you can input A, B, C, D, E, 5 columns. So mean you can solve up to 5 simultaneous linear equations. Okay, to calculate this one, this value, from this equation, now in spreadsheet, is actually I can only key in the right hand side. So the calculate menu I'll erase first, otherwise very messy. So in the spreadsheet, x1 is in, let me look at the spreadsheet. We have column A, B, C. It start with rows 1. So this value is 0, 0, 0. Okay, this cell is A1, A2. Okay. So now you're keying formula in A2, B2, B, C, C2. Okay, so this is A1. Okay, this cell is A1. This cell is B1. This cell is C1. We are going to calculate A2. So, okay, for A2, click the cell A2. Cell A2, we put equal. So the formula in spreadsheet is not natural display, so make sure the bracket 6 plus x2 is stored in cell, this is cell B1, so B1 minus 3, x3 stored in cell C1, so 3 C1 divided by 5. So you go to cell, this is cell A2. This cell B2 to calculate x2. So equal. We have 2 minus. To calculate cell B2. Okay, 2 minus 4 x1 plus 1. The new x1, which is stored in A2. So 4 A2 x3 is still the old one, so C1 divided by 7. Okay, equal to cell C2 equal 9 minus x1 k plus 1. K plus 1 is a new x1 to store in A2. x2 k plus 1, the new x2 stored in cell B2. So 3 B2 k divided by 10. We check properly before we key in. To calculate A2 dependent on B1 C1. 6 plus, this is B1 minus 3 C1 divided by 5. To calculate cell B2, dependent on the new x1 which is x2 and still the old x3, so it's C1. So 2 minus 4 A2 minus C1 divided by 7. To calculate cell C2 depend on the new x1 and new x2. So 9 minus 2 A2 minus 3 A2 divided by 10. So we will calculate this thing in cell A2. So the equal here is alpha equal, so bracket 6 plus alpha B1 minus 3 alpha C1 divided by 2. So you get 1.2. Move to here, alpha equal, substitute this formula, 2 minus 4 alpha A2 minus alpha C1 divided by 1. So you get negative 0.4. Okay, move back to cell C2, alpha equal, bracket 9 minus 2 alpha A2 minus 3 alpha B2 divided 10. And equal. We will check the solution in the table. Erase first, otherwise we see. Okay. So you see 0.78, negative 0.4, 1.2. First iteration correction. Okay. Later on, if you use spreadsheet, you can copy down formula like you did in the Microsoft Excel. So copy options. Go down to choose number 2. To paste down, you go down, press equal. Go down. 1.2. Answer different because we still haven't updated x2 and x3. To exit, you paste more because easy to paste. To exit the paste AC. Go to copy the formula in the table. This formula. Options. Go down. Copy. Go down. Equal to paste. 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 Escape. So AC. We go up to get the formula at the cell C2. Here, this formula. Here you won't see formula because shift menu number 4, number 2 show formula. So now you see the formula that I put in. So to copy options, go down number 2. Go down, equal to paste. 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 Escape AC. Now you can check the solution. Number 3. To see script, to see more decimal place in the go to shift menu again. Okay, spreadsheets. So cell show value number 2. So 652. Okay. Here, this value negative 0.1983. If you want to fix, so shift menu. Okay, number format number 3. Okay, 1. If I want to show 4 decimal place. So 0.1983. Next one 0.8291. And then okay, this is copy it down. 6629. Correct. Next one negative 0.2115. Next. Move to the next. 0.8309. Correct. This is 0.8311. Correct. Negative 0.2097. Correct. Over here 0.6592. So this is correct. Go down. Hit 0.6594. So correct. Move to the right. X number 2. Negative 0.2098. So correct. 0.838911. Correct. One more. This now. 6 is number 5. Okay. So here if one more, get options. Go down. Number 2. Yes. And then hit escape. Go to here. Options. Number 2. Go down. So you can see 7 should be X K number 6. K number 6 because the spreadsheet start K with 1. So 8311, okay, 2098, 6594. So the next iteration is actually no more changes. That's why okay, the solution is 0.9564, okay, negative 0.2098, okay, 0.8311. But in here we stop at iteration 5 because we choose the okay, stopping criteria modulus x number 5, maximum value of x modulus x number 5 minus x number 4, we obtain 0.002, okay, which is less than epsilon 0.005. Turns k the root, the solution for x1 is 0.9564, negative 0.2098, x3 is 0.8311. Okay, so this is solved using the spreadsheet menu. So you know this spreadsheet menu, you fill in 000, you just calculate input the formula for x1, x2, x3, and then you can just paste down easily to obtain the solution. And to calculate the spreadsheet formula, you must clear that spreadsheet. We start the row from 1, and we have only 5 columns in the spreadsheet menu A, B, C, D, E. So you can calculate up to 5 simultaneous linear equations. Okay, the initial value for x1, x2, x3 is stored in cell A1, B1, C1. Then from the Gauss-Seidel iterative formula, you can only input the right hand side function. The equal is actually use the red color equal. So in spreadsheet, it's not natural display. So make sure you have the bracket. So 6 plus x2 is stored in B1 minus 3 x3k is stored in C1. Calculate the first formula. Once you equal this value, to calculate x2k plus 1 in cell B2, this is the formula where x1k plus 1 is the new x1 which is stored in B2, x3 is still the O stored in C1. To calculate the new x3 at k plus 1 in cell C2, we have the new x1 So store in A2, new x2 store in B2. So input these three formula and then you equal, you got the first case row of the result is row number 2. Later on you copy, okay, to copy formula option, go down, you copy. And then you just go down to paste, paste. Okay, this is using the spreadsheet menu. Okay, if you use the calculate menu, we are going to input in the equation base simultaneously. So x1 store in A, x2, okay, step K is a B, x3 step K is a C. So column, okay, this column is get red color column. Stand for calculate simultaneously. Okay, x2k is a B. Okay, and then x1k plus 1 stand for the new x1 which is stored in A. To count this out, this is A. That's why this is A. Okay, C because we still don't have the new one, so okay, C here equal to the C. Okay, later on to calculate the new C, we also label as C. Here, okay, C. So x1 is a new one, this is A. x2k plus 1 is the new one, so it's B. Because okay, here, we just plug in B and C, we obtain the A. So this A value, the A value will be plugged in here. So all the, okay, this clear, the right hand side expression is stored in B. So you got the new B, this new B will be plugged in here. The new A will be plugged in here. Then you obtain the C. So using this technique, okay, you plug in B and C, you obtain the A. Okay, A value, okay, this A value and the C value, okay, we use to obtain this B. Later on, the A and B value obtain plug into C. So to do this, okay, you just need to press, okay, first of all input B is 0, C is 0, then obtain A. Okay, later on, you just press equal, you automatically obtain your B. And then press equal, automatically obtain C. So next you just equal to obtain all the values. Okay, and then I'm going to show also you can directly actually remove equations to solve simultaneous equation of 3 unknowns. In this model, we solve up to 4 unknowns. So you need to key in directly without arrange so that it's diagonally dominant in your calculator to obtain the solution directly. So this is actually analytic. If using Gauss-Seidel, this is numerical. And then find -1 and 3. Okay, key in the coefficient row by row. And then 4, 7, 1, 2. So check 962, then 3, 1, 3, negative 1, 7, 2, 5, 4, 54. Check with the solution we obtain numerically. Numerically, this is approximate solution. Okay, the calculator give you should be exact solution. 6594. So get negative 0.2098 8311. And then you want to 3. Sure, I think you cannot see 3 simultaneous linear equation graph. Let's see. I think you cannot see. Okay, if 2 simultaneous, we can see the graph. Because it's 2D. This one, 3 simultaneous is 3D. We cannot see in 3 dimensions in this model calculator. Okay, but it gives you the rules here. To get QR code, yellow color, press Shift Option button. Use your handphone to scan. Okay, unfortunately, 3 simultaneous is 3D graph. We cannot view in this model calculator. Okay, if you got 2 simultaneous linear equations, you can view the 2D graph. Okay, the solutions, is actually the intersection of the 2 graphs. Okay, so with this, thank you for your attention.